Section 2.6 is ratios, rates, and conversions. I can find ratios and rates, and I can convert units and rates. Big ideas here. Ratios and unit rates can be used to compare quantities. Units and rates can be converted to solve problems. A ratio compares two numbers by division. The ratio of two numbers a and b can be written in three ways. We can write it as a fraction a over b with a colon a to b, or we can just write it in words a to b. For every a units of one quantity, we have b units of another quantity. We can also think of a ratio as a multiplicative relationship. For example, if the ratio of the number of boys to the number of girls in the class is 2 to 1, then the number of boys is 2 times the number of girls. We don't necessarily know how many there are, but we know that if we multiplied the number of boys, or the number of girls by 2, we'd get the number of boys. So we'd multiply both numbers in our ratio here, the 2 and the 1, by the same value to get our exact number. So it's like a fraction that's been reduced. A ratio that compares quantities measured in different units is called a rate. A rate with a denominator of 1 is a unit rate. So if we're comparing miles to hours, saying we drove 300 miles in 5 hours, that's a rate because we're comparing miles to hours. If we simplify that down to 60 miles per hour, per 1 hour, that's a unit rate. Okay, so a rate is any time we compare two different units. So miles over hours, for example, or pounds per bag, or things like that. And a rate with a denominator of 1 is a unit rate. So if we simplify that down so that our denominator is 1, like a miles per hour on our speedometer, for example, that is a unit rate. In example one, we're comparing here. We're shopping for t-shirts. Which store offers the best deal? So we want to know how much it costs for one t-shirt. Okay, we want to know which one has the best deal, which one sells t-shirts the cheapest. So for store A, it's $25 for 2 shirts. So I can write this as a ratio, and if I do it as a fraction, it's easy to reduce. 25 divided by 2 is going to give me $12.50 per shirt. And that's going to be my unit rate because it's per 1 shirt. Okay, store B is going to be $45 for 4 shirts. So I'm comparing $45 to 4 shirts, which I can reduce and get $11.25 per shirt for 1 shirt. So 1 shirt would be $11.25. 2 $22.50, 3 $20, 3 $75, 4 $45. Okay, it's like we broke it down to how much does it cost per 1 shirt. These are our unit rates. Store 3 is $30 for 3 shirts. And when I reduce there, I get $10 per shirt. So we want to know which store offers the best deal. Well, that's going to be whichever one has the cheapest amount per shirt. Which one charges us the least amount for each item. Here, $10 per shirt is cheaper than $11.25 or $12.50. So store C is going to be the best deal. Now, we want to know, if store B lowers its price to $42 for 4 shirts, does the solution to problem 1 change? So if we change this to be $42 for 4 shirts, so $42 for 4 shirts, when I divide that, I get $10.50 per shirt. Did our answer change at all? No, store C is still our best deal because it's only $10 a shirt. Store B is a better deal now, but it's still not quite better than store C. So store C is still our best deal, so our answer did not change there. To convert from one unit to another, such as feet to inches, we multiply the original unit by a conversion factor that produces the desired unit. A conversion factor is a ratio of two equivalent measures in different units. So it's like saying 24 hours is the same as 1 day. They mean the same thing, they're just measured in different units. Or 12 inches is 1 foot. Okay, those are conversion factors because they mean the same thing. And if I took 12 inches and divided it by 1 foot, it still gives me 1 because they're the same thing, they're just written a little bit differently. So, the table on page 814 in your book, you might want to mark, that has some common equivalent units of measure. I believe there's also a set of those in your planner. In example 2 here, we're going to be converting units. What is the given amount converted to the given units? So here, I'm going to start off with 330 minutes. And remember, we can write anything as over 1 to write it as a fraction. And I multiply by a conversion factor. Here I'm comparing minutes to hours. And I need to come up with the relationship between them that's the same. So 1 hour, for example, is 60 minutes. Those mean the same thing. They're equivalent. They're just in different units, the 2 units that I'm using here. To set up my conversion factor, it's important to know which goes on top and which goes on the bottom. Right now I'm looking for hours. So I need hours to go in my numerator because hours is hours over 1. Anything can be written over 1 unless it's already in the denominator of a fraction. So hours has to go in the numerator, and I need minutes to go in the denominator because when we multiply fractions, we multiply straight across. So right now in my numerator I have a minutes, and in my denominator I have a minutes. And anything divided by itself cancels out. Then we can plug in our numbers with our values. So 60 goes with the minutes, 1 goes with the hour. We multiply fractions straight across. So I get 330 times 1 hour over 1 times 60. And we reduce to get 5.5. So 330 minutes is the exact same as 5.5 hours. It's just written differently, but still equivalent. For B here, I start off with 15 kilograms. And remember, we can write that as over 1. We can always write things as over 1 to put them into a fraction. I need to go from kilograms to grams, so I need to come up with the relationship between kilograms and grams. Well, if we look on page 814, I think it was, it tells us 1 kilogram equals 1,000 grams. Kilo actually means 1,000, so 1 kilogram is actually 1,000 grams. Direct translation there. So we need to figure out what goes on top. Well, here I'm looking for grams, so I'm going to put grams on top. And I need my kilograms to cancel out. So remember, when we multiply fractions, we multiply straight across. Anything divided by itself is 1. It cancels each other out. So I need my kilograms to cancel because all I'm looking for is grams. Now we plug our values in. 1 goes with kilograms, 1,000 goes with grams. And since I have the label I'm looking for here, I can multiply straight across. 15 times 1,000 over 1 times 1, which is just going to give me 15,000 grams. C, I have 5 feet 3 inches, and I'm going 2 inches. So this 3 inches is already where I need it to be. So I'm going to leave that alone for now. I'm just not going to forget about it, so I'm going to box it in or circle it or something so I know to come back to it. And I'm just going to switch from feet to inches. So 5 feet. Again, I'm going to multiply by my conversion factor. When we multiply fractions, we go straight across. 1 foot is the same as 12 inches. That's my comparison. Now I need to figure out how I'm going to set up that conversion factor. Okay. Feet go in the denominator. Inches go in the numerator. I'm looking for inches, so inches go on top. When I multiply across, feet divided by feet cancel, and that's what I'm looking for. I'm looking for inches, so again, they go where I'm looking for them, here in my numerator. And if I have the same thing in my numerator as I do in my denominator, they cancel each other out. 1 goes with feet, 12 goes with inches. 5 times 12 inches over 1 times 1 gives me 60 inches. Don't forget that we have 3 here though, so I'm going to add those 3 on. And 5 feet 3 inches is the same as 63 inches if the entire thing is switched to inches. Now, what is 1,250 centimeters converted to meters? Well, I'm starting off with 1,250 centimeters. And I'm going from centimeters to meters. So I need to relate centimeters to meters. Well, 100 centimeters gives me 1 meter. I need meters to go on top because I am looking for meters, and I need centimeters to go on the bottom because when I multiply fractions, I can multiply straight across. And anything divided by, remember, fraction bars are division, itself gives me just 1. Then we plug in our numbers. The 100 goes with centimeters and 1 goes with meters. We multiply straight across. Simplify. And divide. And I get 12.5 meters. So 1,250 centimeters is the exact same distance as 12.5 meters. So if we were using like a tape measure that was in meters, these would both measure the same distance. It would just depend on which unit we were using. The CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is a tower? Use the fact that 1 meter is approximately 3.28 feet. That should go there, sorry. So we're going to start off with what we know, 1,815 feet. And we multiply by our conversion factor, which is here. We want to know how many meters, so meters has to go on top. And I need feet to go in the denominator because when we multiply fractions, we multiply straight across. And anything divided by itself cancels out. So 1 goes with the meter and 3.28 goes with the feet. And it's approximately here because when we switch from customary to metric or from English to metric, it doesn't necessarily always transfer exactly. They're usually approximate values, like 2.54-ish centimeters in an inch, 3.28 feet-ish in a meter. So instead of having like an exact value here, we use the approximate value. So we multiply straight across here in my numerator and in my denominator. Simplify. Then divide, which gives me approximately 553.353659 meters, but it says about how many, so I'm going to round to the nearest meter, 3 rounds down, and say it's about 553 meters. So approximately. And remember that squiggly equal sign means approximately or about. Now, a building is 1,450 feet tall. That's what we start off with. We're going to multiply by our conversion factor. We want to know how many meters, given the fact that 1 meter is 3.28 feet. So, meters is what we're looking for. It goes on the top. Feet is our other part of our conversion factor, the other unit we know. And since we're multiplying fractions, we multiply straight across. And that allows us to take anything divided by itself to cancel each other out. 1 goes with meters, 3.28 goes with feet. We multiply across here. Simplify. And divide. I get 442.073171 meters, which again I'm going to round. 0 rounds down, so 442 meters approximately. And I'm going to stop here and continue this section in another video.